Alright guys, I wanted to make a video talking about a couple of different strategies that you can do when you're trying to prove or verify or establish an identity. So the thing is with identities, we already know the answer. We're going to try to get this side to look like this side. So the important thing here is to show work for how you get there. And so there's a couple different little tricks that you can use depending on what it looks like in the very beginning. And the only thing that really here you have to remember is that you can only manipulate one side of the identity. Or at least that's what I want you to do, is only manipulate one side. Okay, so remember that these are not equations. We can't multiply both sides by 2 or do anything crazy like that. We can only use the identities that we have memorized. So let's start off. The first thing I would do in this problem is change everything to sine and cosine. Because immediately up front, I don't see any identities that I recognize. If these things were squared, it'd be perfect, but they're not. So let's change everything to sine and cosine. So 1 over sine minus cosine over sine. 1 over cosine plus 1. Okay, so notice here that both of these have the same denominator, so I can combine them. Okay, and I'm going to do kind of the same thing over here, is get a common denominator. So I'm going to rewrite that 1 as cosine over cosine. Alright, so I have 1 minus cosine over sine times 1 plus cosine over cosine. Alright, so then multiplying across the top, we're going to get 1 minus cosine squared over sine cosine. And then recall from your Pythagorean identities, 1 minus cosine squared is sine squared. And then finally, sine squared divided by sine would be sine over cosine, and that is the tangent. So I finally reached what I wanted to, what I had on the right side over here. So this is not necessarily the easiest way or the fastest way to work the problem. It's just one of the ways that would work. We could have gotten away with just distributing at the very beginning. But I don't like to do that if I don't have to. So, all right, next problem. So again, here I don't see any identities up front. So let's start this one off also by changing things to sine and cosine. So remember that tangent is sine over cosine. Okay, so on top I'm going to get sine squared here, sine times sine over cosine, and I'm going to change this cosine. I'm basically going to multiply that part by 1. Cosine over cosine is 1. So I get sine squared theta plus cosine squared theta. And since they have both have the same denominator, I can add across. And then sine squared plus cosine squared, as we know, is 1. And 1 over cosine is secant. Okay, so we've established 2 identities so far. 1 and 2 are good. Alright, let's move on to some new tricks. So that was changing things to sine and cosine. We can see that that's a good idea. Alright, so in number 3 here, we're going to take a different strategy. So something that we know, looking at this problem, is on the top here, we have 2 cosine squared minus 1. And on the bottom we have cosines and sines. And in the answer we have cosines and sines. So what I'm probably going to want to do here, I know some identities for cosine squared. And I'm probably going to want to start changing the top here so that I can get a cosine and a sine. Alright, so on top, remember that 2 cosine squared will be the same thing as cosine squared plus cosine squared. Alright, so 1 plus 1 is 2. That's pretty basic. Alright, now remember that cosine squared minus 1, that's a Pythagorean identity. That's the same thing as negative sine squared. Alright, this is looking good. So notice the top is a difference of two squares, so it'll factor as cosine minus sine, cosine plus sine, over cosine minus sine. And then finally the cosine minus sines will cancel out, giving cosine plus sine, which is what I wanted to have. If you want to write it the correct way, that's fine. We know that addition is commutative, so the order doesn't really matter. Alright, so in that problem I had a cosine squared that I know some identities for. In this case, I only wanted to change one of my cosine squareds there. In the next problem, notice that this is the only place that I have a sine squared. So I'm going to go ahead and just change the whole thing there in this case. And I'm actually going to show you two different proofs for this one because there's two that are pretty neat. So looking at this, I know that sine squared is the same thing as 1 minus cosine squared. Alright, so I just changed the sine squared on the inside. Then I'm going to distribute. 2 minus 1 would be 1. Oh, I guess I need to finish writing down the denominator. So yeah, 2 minus 1 would be 1. So I'd have 1 minus 2 cosine squared over cosine squared. At this point, I recognize that I have one term here, and I have two terms in my answer. So I'm probably going to want to try to split this apart. So 1 over cosine squared would be secant squared, and negative 2 cosine squared divided by cosine squared would be minus 2. So I can split it apart into two different fractions. Really, you probably want to show some work for that. So let's write down the intermediate step there, that we're splitting this apart into two different fractions, and then 1 over cosine squared is secant, and the cosine squareds cancel there. Okay, so I said that there was two ways that I was going to show you how to work this problem. It just so happens that we could have recognized that we had one term up here and split this apart a little bit faster. So we can make this 2 sine squared over cosine squared minus 1 over cosine squared. So sine squared over cosine squared is tangent squared, and 1 over cosine squared is secant squared. Recall that tangent squared is the same thing as secant squared minus 1. Then distributing the 2. And finally combining the secants. So two different approaches there. They both have kind of the same steps involved. It's just the order that you do them in. All right. So on this page so far, we learned about changing things to sine and cosine as a way. One cool method is you can, if you have something like this where you have 2 terms or 3 terms on top and just 1 on the bottom, you can split it apart and make separate fractions. Or if you see things like sine squared and cosine squared, you can change those or split them apart and just change part of it in this case. So those are some cool little tricks you can use there. And I got 4 more problems here that I want to work through real quick. So if you haven't caught on already, it might be a good idea for you to pause the video before I start a problem and see if you can work it out yourself. And then you can resume play and check to make sure you were doing it right. Alright, so another cool trick you can do with identities, especially when you see something like this where you have cosecant minus cotangent on the bottom here, and your answer has cosecant plus tangent, you're probably going to multiply by the conjugate of the denominator. So we're going to multiply the top and bottom of this equation by cosecant plus cotangent. And really that's a good thing to see, even if you're not really sure if you should use the cotangent. Another cool trick that you can do is that if you have something in your answer, you can always multiply the other side by 1 and put things that are in your answer into your equation. So in this case here, on top we're going to get cosecant plus cotangent. And when I distribute out the bottom, I'll get cosecant squared theta minus cotangent squared theta, which is an identity, and it's equal to 1. So we arrive at our answer pretty quickly in this case. Alright. So multiplying the top and bottom by the conjugate, another really good trick to know. Looking at number 2, notice that we have cosecant to the 4th minus cotangent to the 4th. That's a difference of 2 perfect squares. So another cool trick that you can always think of having in the back of your head is factoring. So this will factor as cosecant squared minus cotangent squared times cosecant squared plus cotangent squared. And it turns out that cosecant squared minus cotangent squared, as we've already discussed, is equal to 1. So again, this problem is solved rather quickly. You'll notice as I work through most of these examples, I very rarely change things to sine and cosine. I just got through grading a whole bunch of tests where almost every single problem the students tried to change everything to sine and cosine. And usually that will help you, I guess, in some cases. But it also adds like 3 or 4 extra steps to each proof. So try to avoid doing that if you can. Just some ideas. Alright, so looking at number 3 here, cosecant minus sine equals cotangent times cosine. So notice on the left side we have 2 terms, and on the right side we only have 1. So there's going to be something that we can do to this to try to combine them together. And one cool thing we can do is if we have fractions, for example, if I'm starting off on the left side here, cosecant is the same thing as 1 over sine, and I can multiply and get a denominator on the right side as well by making it sine squared over sine. So we got a common denominator. Now I can add the fractions together. And recall that 1 minus sine squared is cosine squared. And finally, that cosine squared is the same thing as cosine times cosine. And that cosine over sine is cotangent. And if you feel so inclined, you can reverse the order there, because multiplication is commutative as well. Okay, so another pretty easy trick there. So we know that we can sometimes split fractions apart. We can also combine fractions if that's the way that the problem tends to work out. So, all right, one last problem here, number 4. So notice again I have 2 terms and I have 1 term, so I'm probably going to want to try to get a common denominator here so I can add these fractions together. So on the left side I'm going to multiply by 1 minus cosine, or sorry, 1 plus cosine over 1 plus cosine. And on the right side I'm going to multiply by 1 minus cosine over 1 minus cosine. Alright, so on the left side when I multiply it out, I'll get 1 plus cosine on top over 1 minus cosine squared on the bottom. And on the right side, 1 minus cosine also over 1 minus cosine squared. Alright, so I have a common denominator now. I can add the fractions. So 1 plus 1 on top is 2. Cosine plus negative cosine is no cosines. And recall that 1 minus cosine squared is sine squared. And that 2 over sine squared is the same thing as, I can never write cosecant. I don't know why that is. It's the same thing as 2 cosecant squared, which is the answer we were going for. Alright, so there's a couple of tricks you can use to help you solve identities problems. So just as review, we talked about changing things to sine and cosine like we did in the first two problems. We talked about looking for identities that you know, like changing cosine squared into 1 minus sine squared, or in this case, we changed 2 cosine squared into cosine plus cosine, and then used cosine squared minus 1 to change. We also talked about splitting things apart when you have 2 terms in your answer. And 1 term over here, you can split this apart into 2 different fractions. Multiplying by the conjugate, another good trick to know. Factoring is always good. Look for factoring because those problems will typically jump out at you. Again, getting a common denominator can help you go from 2 to 1. And in this case, we also had to get a common denominator to go from 2 to 1. There's just more steps involved. One last thing I want to talk to you about is some identities that aren't used very often. So there's actually 2 sets that I want to talk about briefly, in case you've forgotten them. When we went through the unit, there weren't any of these in the book. So I want to talk about the cofunction identities and the even and odd identities really quick. We'll do the even and odd first. So even and odd, there's only 2 even functions, or even trig functions. That would be cosine and secant. And there are 4 odds: sine, cosecant, tangent, and cotangent. So what does it mean to be even or odd? Well, if you're an even function, like cosine is, cosine of a negative angle is the same as cosine of the positive angle. This is because even functions have y-axis symmetry. Okay, so secant has the same property. Secant of negative theta would be secant of positive theta. Alright? If you're an odd function, however, then you have origin symmetry. So if I take and I plug in a negative angle there, that's equal to negative sine of theta. Okay? Same idea with cosecant. Cosecant of a negative angle would be negative cosecant. Or tangent of a negative angle would be negative tangent. Or cotangent of a negative angle would be negative cotangent. Okay? So that's kind of cool stuff there for you to know. Alright. Cofunction identities. Functions that go together. They cooperate. So we know that sine and cosine go together. That cosecant and secant go together. And that cotangent and tangent go together. So sine and cosine, secant and cosecant, tangent and cotangent. Easy to remember the cofunctions because they go together. Just put a co in front of the name and you've got the one that goes with each other. So the actual identity there that they're going to have is that if you take an angle and you subtract it from pi over 2, for example, the sine of pi over 2 minus theta, well, that's going to give you the cofunction, cosine. Likewise, cosine of pi over 2 minus theta, that's going to equal sine. Same idea for cosecant down here. Cosecant of pi over 2 minus theta is secant of theta. Secant of pi over 2 minus theta is cosecant of theta. And same idea for tangent. Tangent of pi over 2 minus theta is cotangent. and cotangent of pi over 2 minus theta is tangent. Okay, so you got your cofunction identities, your even and odd identities. You'll need to know those. So coming up, we have a couple more identities to talk about in the next unit. We'll go through and do some half angle and double angle identities, talk about I think the sum and difference identities, stuff like that. So lots of fun to look forward to. So hopefully this video helps. If you have any questions, feel free to leave a comment below. Otherwise, good luck doing what you do.